Hi everyone. So I'll be introducing the math topic of proportional relationships. So the objectives right here is to understand the concept of proportional relationships and identifying the proportional relationships from tables. So mainly in this video we're going to be discussing how you guys can identify proportional relationships from tables in general. So, a proportional relationship is the relationship between two quantities where the ratio or the rate between them is always constant. So, meaning that it is always constant when using the formula, basically. And I'll be showing that formula right now. And the proportional relationship equation is k equals y over x. So, that's what that first bullet point meant right there. So, that k value has to be constant, and the letters y and x are the variables, which can change, and the letter k is the constant of proportionality. The constant of proportionality is the constant ratio between y and x variables. So when you're using a table, you want to see if that k variable is always the same. That's the key point when you're looking in a table. And you want to make sure it's not different every single time, because therefore it will not be a constant proportionality. Now we're going to do some examples to show whether we can determine one is or is not a proportional relationship. Looking at the first example right here, you may be wondering, how can I determine if something is a proportional relationship? So what you can do is see the pattern for the number of apples and the total cost y. So we're going to look at the x column right there. So what you're going to do is see how the pattern is going up by. So from 1 to 2, 2 to 3, 3 to 4, and 4 to 5. You can see right there the pattern is increasing by 1 every single time. So you can see when you add 1, you get 2, 2 to 3, add 1 to 3 to get 4, and add 4 to 1 to get 5. Now we're going to do the same thing to the y column right there. So pretty much do the same thing. So you can see from 2 to 4, 4 to 6, 6 to 8, 8 to 10. You'll notice that it's increasing by 2 every single time. Now what we're going to do is we're going to use that formula for the proportional relationships and see if it is a proportional relationship. So remember from where I was mentioning about the definitions and all that. So I had k equals y over x. We're going to see if it's always the same for k. So you can see right there the pattern is constant. So we have 2 over 1. Where I got the 2 from is from that value y, from that formula. Y is equal to 2, which is the pattern, and where the 1 came from is from the x, which is the pattern when I was seeing how it increases from 1 to another number. Now what we're going to do is divide 2 and 1, and you're going to get k equals 2. Is this a proportional relationship? The answer is yes, it is a proportional relationship because the constant of proportionality is the same, meaning that the k value is always the same, constant. So you can see that every time we are dividing 2 and 1, and you'll always get 2. So that is why it is a proportional relationship. Now, we're going to do another example where it is not a proportional relationship. So you can see right here, we're going to do the same thing again. Looking at the x column, you can see that we're increasing by 1. But if you look carefully when you look at the y values, you can see it increases at a different rate. So we got 5 to 10, which is 5, 10 to 18 is 8, 18 to 25 is 7, and 25 to 30 is 5. So if you do the math right here, right, k equals y over x, if we look at each and every one of them, so let's do the 5s first, right? So 5 for y, 1 for x. 5 divided by 1 is 5. So okay. Now let's do the one for the 8 divided by 1. So 8 for y and 1 for x. 8 divided by 1 is 8. And then you have 7. So you do 7 divided by 1, which is 7. So you can see right there that we have 3 different k values. So what does that mean? It means it is not a proportional relationship because the constant of proportionality is not the same. So you can see right here we have 3 different values. So when you have 3 different values, then you'll know off the bat that it is not a proportional relationship. It has to be only one and just only one constant proportionality. It has to be the same number, in other words. So hopefully that kind of made sense. We'll do a few more examples so that you guys can understand the idea. Okay, so I'll let you guys do this question on your own and see if you can come up with an answer. Okay, guys, so let's try to do this together. So if you look at the pattern right here, you can see that it is going up by 3 for the first time from 3 to 6, then 4s and 6. And same thing if you look from the right side, you should get these following numbers. So you can see right here that the numbers may be different, and it's not like a constant pattern. You may be wondering, is this not a proportional relationship? I would not come to conclusions right away, because I would do is take each number and divide it from each other. So like, for example, 9 and 3, 12 and 4, and the 18 and 6. So here's what I mean by that. So what I'm going to do is divide 9 and 3. So 9 for y and 3 for x. When you do that, you get k equals 3. So far, pretty good. Okay, now we're going to do the 12 divided by 4. So when you divide 12 and 4, 12 for y and 4 for x, you're also going to get 3. So that's what I was saying. You shouldn't come to quick conclusions. I would check my work before I make those quick conclusions. Now for the last one, let's make sure if it is also 3. So what I'm going to do is divide 18 and 6. When you do that, you're going to get k equals 3. So right there, you can see that all the k values are all 3. What does that mean? It is a proportional relationship because the constant of proportionality is the same. So regardless if the pattern looks like it is not constant, and it looks like it may not be a proportional relationship, it is always safe to make sure you use that formula and see for each and every one of them if it is a constant of proportionality. So make sure you divide your y value with your x from those patterns from each one, and hopefully you get the same k value for them. So there will be cases, something like this, where it can be a proportional relationship. Hopefully this one, whatever I just discussed right now, made sense. Okay, let's do one more just to make sure you guys got the idea. Okay, try this question on your own and see if you can come up with your own answer. Pause the video. I would highly recommend you guys doing that. Okay, guys, welcome back. We're going to go over this question together. So you should come up with the following. So you should see the pattern is going up by 1s. And then you should get like a random pattern right over here. So 6, 5, 3, and 2. We're going to use the formula. You can see that when you divide 6 and 1, you get 6. 5 divided by 1, which gives you 5. 3 divided by 1, which gives you 3. And 2 divided by 1, which gives you 2. What does that mean? It means it is not a proportional relationship because the constant of proportionality is not the same. Meaning that the k values are not the same. It has to be the same. Only one. It can't be different numbers. Alright guys, so we reached the end of the lesson. So before I end it, I just want to go over some stuff that we learned. So we've learned how to see the patterns of the table and determining if the table is proportional relationship by using the formula k equals y over x. So hopefully you guys found this video very useful. And hopefully you're able to understand the idea of how to determine if a table is a proportional relationship. And if you have any other questions or anything like that, then be sure to write it down in the comment section down below. And I'll be sure to answer them. And I hope you all have a great day.